Thank you. Thank you. This is going to be a bit different for me because I don't usually do kind of educational or instructional kind of things, but I'm going to have a go. And yeah, and you'll all just fucking sit and listen. For those that do know me, you're probably kind of vaguely used to seeing me farting around with coding in a live situation to make music. I'm going to do that tonight, but I'm not doing it with modular stuff. I'm just doing it with my laptop tonight. And I'm doing it in a language. It's kind of commonly known as an esolang or esoteric language. It's called ORCA. It looks proper mental, and it kind of is, but also the principles of it are very, very simple. It's made by these 200 rabbits. Just a very brief thing about them. I think they're amazing. They live on a tiny boat. One of them is an artist and writer. The other is a coder and software developer. And they wrote this as well as a bunch of other really light kind of virtual machine style programs. Yeah, I just think they're ace. If you have time to check them out, you can look them up by 100r.co and you can read all about them. Cool, so this is just a little placeholder patch that I made for tonight. I'm gonna hit play. I'm doing this in a browser version, but there's other versions of ORCA as well. But fundamentally, they all just create MIDI data and play lovely things like this. And basically, every letter of the alphabet in ORCA has a different purpose. So if we look at the green text here, we'll see a bunch of random letters like R, which will just create random values. And ORCA counts in numbers, but it counts in hex. So basically it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when you get to 9, A for 10, B, C, D, E, F, G, all the way to Z. So there's that. And on this one, the kind of built-in browser version of ORCA, it has some nice synths that you can kind of see up here just built into it. So usually ORCA doesn't make any sound on its own, but the browser version's got these built-in synths. It's also got built-in effects, which I'm using a little bit of here, as well as some samples and some drums. And in this little area here where I've got this nice little kind of welcome speech, I've commented out the text. If I get rid of all that, oh, it's because it's all lowercase. So that's a good thing to mention. So in ORCA, every letter has its sort of caps equivalent. This is A. It will take two things and add them together. So 2 and 4 make 6. Or B, which takes one away from the other. So 4 minus 2 is 2. But there's also the lowercase equivalents. And these won't do anything on their own unless they're struck. For people that are used to things like maybe max MSP or pure data, they call this a bang. So in ORCA, we can also create bangs. You'll see here now every time that little A gets struck by a little star, it's basically activating it. So we can do it with another one. So here's C. C is a counter. It will just count, usually to 9, and then back down again. But you can set it to count to whatever you want it to, which is pretty cool. If we do little c, it's only going to count every time it gets that bang. D stands for delay, and it's basically like a clock divider. It takes whatever your current frame is, and by doing it on 1, 1, we get like 16th notes. 1, 2 is more like 8th notes. You can get thirds. It's quite nice for polyrhythms and stuff. So yeah, then there's a bunch, the actual sort of topography of Orca is that it goes top to bottom and left to right. So it creates situations where you maybe want to put like exact, like look at this 2 that's highlighted here. If I want to change that, I can't put anything above it because I've already got shit in there. Can't put it next to it, already stuff there. So it creates a situation where you're like, fuck, I want to put something in that specific place. How do I do it? So there's like an op for that, thankfully. That's really cool. It's called X, and it will write a value at a specific kind of coordinate. It's the teleporter op, which I think is really cool. So here I've got the value 2, but let's say I want to put in a random number between like 2 and 5. I'm going to put 2, 5 here and then hit R. Okay, and then next to the X we've got these 2 arguments, and you can actually see at the bottom of the screen, maybe just, it's an X and a Y coordinate. I'm only going to be dealing with the X coordinate, so I'm just going to fill that one in. So frame 0, frame 1, 2, 3, 4, 5 is where I want to get to. So I'm going to put 5 in here. And we should hear vaguely high-pitched because it's the octave. So a good thing to talk about is how like a typical Orca MIDI command is. You can use the semicolon, or the colon, sorry, and then it's channel, so MIDI channel, then octave, then note, then velocity, and then length, so like the actual length of your thing. And that's like, if I come out of this, I'm just going to refresh it so we've got clean slate with no effects or anything. I can show you what just the very most basic command would be. So we'll just do the semicolon 1. We'll pick, what will we pick? We'll pick a TR8, 808 on the second octave on note C, and we'll just bang that. So this needs a bang as well. We have a note, and this is basically the foundational idea of Orca in general, is that you just point it to a value and you bang it, and it will just make that note. Right, you just bang it, and then you can copy and paste that, and then we could pick a different channel. Right, pretty cool. We could change this up. Right, what the fuck? How did that happen? Right, so let's, every good dirty beat needs a backbeat, so I'm gonna add a backbeat now. What do we want? I think the gabber one's gonna be fucking gnarly. Let's go for that. Oh. Oh. Let's speed up the tempo a bit. So that's all very well. So I like personally, I think Orca is excellent at drums because it's like it's very core. It's just like really low level math, right? So you can create lists. Like we could use the T op now. Let me just fucking take those off a minute, or we're all gonna have bleeding ears. So track, T stands for track. It's got 2 arguments, the length, so we could do 8, and then key, it's basically a step sequencer. So you need something to tell it, like which step am I currently in? And the best thing for that is a counter. So if we set a counter to 8, we're gonna step through the sequence. And I'm gonna just do some 0s and 1s. And now what we can do is we could use F, which stands for if. So anybody who's like into computer science or does that for work, this is logic now that we're dealing with and logic. So it basically checks 2 states. Are they both on? Then do this. If one is on and the other isn't, then don't do it. So we can use this, and we can also use that for like triggering a drum or something. Let's do deep. That sounds brooding, doesn't it? Fucking ridiculous. jumper, it will move one output down a square. So it's a nice way of getting around the kind of Sudoku-like behavior of Orca. So it's pretty cool. We've got some logic-based drums. We could still add like a 4 on the floor here if we want. I like that. Which is pretty cool. Then we could add like some Euclidean rhythms. They're really nice. So U stands for Euclidean, and that's basically like how many beats in a certain amount of steps. So here I'm going to say I want 2 beats in every 7 steps, and I'm going to do that on the Vermona drum machine. Right, gnarly. We can turn up the volume using the velocity. It's quite nice. Yeah, I'm into it. So, that's kind of a lot of what Orca can do. I mean, obviously there's like all the operands here. We can have a quick scroll through them. Oh, here's a fun one that we've not looked at yet. The cardinal directions. So one of the kind of, this is probably the most like Orca-y thing about Orca is that you can do stuff like this. I'm just gonna create this like wall of drums, and then let's just do HIJKLMNOP, and then we'll just set them as random variables too. Okay, and then we've got this G, which stands for generator or generation, and it's basically saying like whatever is in its little neighboring column here, which I've got an E, it's gonna like put it somewhere, or it's gonna create it based on the coordinates you provide it. So I'm gonna do length is 0. I'm gonna do y is 0, x is. Let's see what this does. Okay, that's the wrong direction. I want to go here instead. So what you can see is it's generating, it's birthing these E's. And the thing that's really cool about the E's being birthed is that when an E is placed, you'll see if I just place one here, they move east. That's what they're designed to do. So we can just have this plonky drum machine. And we can speed this up. Vaguely drum circle sounding. One last thing I want to just get into briefly before I start an actual miniature performance is that there's also effects built into this version of Orca, and you can treat those effects exactly the same way as I'm treating everything else, and that like you would maybe sequence a melody, you can sequence the variables that the effect needs. So now you've got like step-based sequencing for like your distortion or whatever. So I'm going to do that as well. So what I'm going to do, I'm just going to increase the length of my E spawning capabilities, and I'm going to add some more equals down here, because equals is shared by, you can see on the screen, but effects and drums both run on the equals channel. And then what do we want? Maybe distortion. Do a couple of distortions, and I'm going to do some reverb as well, which is on channel 7. Distortion, like crank up to 55 and then come down to like 16, and you can do the same with the reverb or whatever, just get really fucking gnarly. pretty cool. And one, should I save it to the end? I'll save it to the end. I'll do one more really stupid thing right at the end. So bear with me just 2 seconds. 6's drums. 1, 2, and 4. Okay, so now comes the serious performance, guys, so please be quiet. So let's do like this and this. Oh, I've done that in the wrong place, haven't I? Silly me. So I've got some other instruments just queued up in Ableton here that are also running off MIDI. Just listening. So with any luck, we should have some sound in a second. Let's try on 0, please. Oh dear. This was the worst fear realised. What's going on? Okay. That's fine. What I'll do. Oh. No. Let's go into the other worker and see if he wants to play any nicer. This is just the dedicated program version of it all. So let's just try a test. Are you going to play a note for me? Nope, you're not going to play a note for me either. Why not? Is it because I didn't set the fucking audio? I bet it is. Yep, it's coming out my headphones. Excellent. That's really helpful. Thank you so much. Okay, just behave. Oh, excellent. I just love technology, because this fucking projector decides that it doesn't want to. Oh, hello, you've joined us. No, I don't want to save. Right, sorry folks, bear with me. I should just left that fucking gabber on for you. That would have maybe I should just do that. Just one gabber kick, endlessly playing over and over again. It's not going to get old anytime soon. spend so much time trying to get everything working, but I've got one last thing to do, and because I'm using the web-based version of ORCL, it's a bit laggy. It's not the most stable of things. It relies on the